Okay, so today Aspen and I are going to explore soap. The magic of soap. You're going to need some dish soap, some milk, water, shaving cream would be good, and some food coloring. We're going to look at why the chemistry of soap is so much fun, and you can even dye some eggs for Easter. So let's get busy. How much do oil and water like each other? This is a pan of water. Let's add some food coloring to it so you can see the water. Now can you see? There was something hidden on that water. It's some oil. The oil doesn't like my food coloring because my food coloring likes my water. The oil and the water don't like to mix, even if I try and mix them. Mix, mix, mix. Yeah, no matter how I mix up my oil and water, it breaks into some smaller blobs, but really, it's big blobs, and they don't like each other. No matter what I do, the oil and water don't like to mix. The oil is afraid of the water. It pushes it away. It's hydrophobic. So what happens if I add some soap? We're always crazy about washing our hands with soap. I wonder why. Let's add some soap. It pushed everything away, and now the soap has made the oil in little concentrated blobs again, but if I mix it really well so that the soap is allowed to touch all of the oil, what do you think is going to happen? Is it going to form one big blob? Is it going to disappear? Is it going to all go to the bottom? What do you think? Well, when I'm done, it has broken the oil into tiny little blobs, and gotten them away from the big, huge blobs of greasy oil. And now they're mixing with the water a little bit better. So you can imagine if this was my hands and I was trying to take the oil off my hands, to take the dirt off my hands, how the soap would allow the oil to be attached to and the water and allow it all to come off with the dirt. What else can we do if we mix watery, oily mixtures with soap? Our initial experiment today, you need some milk, you need some food coloring, and some dish soap. Milk is mostly water, but it also has some fat in it. Look, it always says the percentage of something or other. What's that percent? It's the amount of fat that is in here. For every 100 bits of milk, there is 1 bit of fat and 99 bits of water. The food coloring and the milk aren't really doing much. They aren't relating to each other other than sitting there and slowly spreading. And here comes the soap. Just 1 drop. 1 drop. I'm going to put it in the middle. Ooh, actually, that was more than 1 drop. What is going on? I'm going to put another bit over here. Oh my goodness. Wow, that's so cool. Why is it doing that? Soap that we've been washing our hands with, dish soap, bar soap, all kinds of soap, its best job is to allow oil and water to like each other. Normally, oil and water don't like each other at all. But soap has one end of it that likes to attach to water and one end of it that likes to attach to oil, and the oil attachy end is very strong. And as you can see, it is attaching and actually running around and drawing to it all of the oily droplets in the milk. It is continuing to draw more and more of the oily droplets into the soapy spot, and in fact, the more it draws in, the more it pushes the water out of its way. And so it continues to pull and push the milk ingredients all around the dish. And if it slows down, it means that we have connected as many oily and soapy ends as we can, so maybe it might help if we add a little more soap. And we'll know we're all attached up with the oil when adding more soap doesn't cause any more stirring of the milk. Oh, it's so pretty. Other experiments for you to extend this: try it with different kinds of creamy, milky products you might have in your fridge. You could try coffee cream, you could try whipping cream, you could try skim milk, you could try what about things like soy milk or oat milk? They have a fat content and a water content. It would be interesting to see if this experiment works in those. And it would be very interesting to keep a bit of a track, an observational track. That's what scientists would do. Is it very responsive? Does it run out? Or maybe you could even time it. You could time how many seconds it takes for the one drop of soap to stop mixing with the colors. But you'd have to be very careful to add exactly the same amount of colors and the same volume of milk or milky product each time. Otherwise, just make it super fun. It's so beautiful. See which one works best for you. We should all have been doing a lot of hand washing lately. So if I'm using a bar of soap and I'm washing my hands, I can make lots of nice sudsy lather. So remember, our soap has this positive and negative side. It's allowing the water and the oils on my hand to combine to wash away the dirt that might be attracted to the oil on my hand and all the germs that are attached to that. Now the thing is, I really can't get a huge bunch of soap going by sudsing it up. I suds it up, I mix the soap and the water and the air to get bubbles. Yay! But look at what I can do with shaving cream. This is also soap, and it mixes with water and air and something that will push it out of the can, like butane. And look at that. Chemists and engineers have come together to make a foam that will stay even after I poke it. Look, I'm poking away at this foam. Yeah, it's never going to get very big. This foam is huge. It's so cool. And so, thanks to engineers and scientists, we have this cool, stable foam. And now if I add some pretty colors to that, my food dye, and I have some paper, or even better, an egg, maybe a hard-boiled egg so that you don't break it, but an egg nonetheless. And then I take, a stick or all sorts of different, you could use a Q-tip or a stick or a toothpick or a knife to make a pattern. And then I'm going to use a piece of recycled paper, tap it down to touch it, and pull it off. Well, that's kind of interesting, but it gets even better when I rinse it. Now I've rinsed all the soap off and I'm left with the dyed paper, or if I'd done it with an egg, the dyed egg. The food coloring actually attaches itself to the water-loving paper or the water-loving egg, and you end up with a permanent color that's really pretty. Something you couldn't have predicted if you had tried to draw it on there. Super cool, thanks to the magic of soap.